Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. Amongst our videos, you'll find topics ranging from beginning algebra through calculus, more advanced topics as well. If that's something that you're looking for or interested in, please consider subscribing and checking out some of our other videos. Okay, let's get into the current one. I want to take a look at transformations of piecewise functions, in particular vertical shifts. I want to look at it two ways. One, if I take the graph of a piecewise function, so I have the graph, what does it look like if I do a vertical shift? That's then going to motivate how do I come up with the function expression for a vertical shift. If I want to just completely ignore or not use the graphs at all as an aid to come up with the expression, how can I generally do that? Let's take a look at the following example. Let's say I've got the function expression negative x squared if x is less than or equal to 0, and I've got, say, the square root of x plus 1 if x is positive. Let's take a look at what that graph would look like. All right. Remember that the negative in front of an expression, in front of a base function, is a reflection in the x-axis, making all these all the function values negative, or at least not positive. If x is less than or equal to 0, that is including 0. What that means is I have the parabola that would have been in the second quadrant reflected over the x-axis and going down into the third quadrant. And again, it's including the origin. Square root of x plus 1, remember this plus 1 is a vertical shift of the base function. I'm not including 0. That means I would have a y-intercept or a hole at the y-intercept, and then the graph would continue on like this. Okay. All right, this is the shift of that function, or the graph of that function f of x. Now let's take this and let's shift the graph. Shift the graph 2 units upwards. What does that then look like? Let's take a look at this portion of the parabola. Well, what I can do is I could take one individual point, move it, and then the rest will follow along. Let's take the point that's at the origin. If that shifts vertically upwards 2 units, that would put me this point, which is closed in, move it 2 units upwards, and then the parabola will follow along. This portion here of the square root function, well, the y-intercept, right, there's not actually a y-intercept, there's that open circle there, but that point would move just like this solid filled-in point would, and that would move up to the y equal to 3 value, because it's already starting at 1. If I shift that up 2 units, and then the square root function would continue from there. This right here would be the function, let's call it g of x. And what would the function expressions be for that? This is the parabola negative x squared, but then shifted upwards 2 units. That means it'd be negative x squared plus 2. And when do I use that function expression? Well, notice that the transformation was vertical, so the inputs are not going to change. I'm still going to use that function expression when x is less than or equal to 0. And for the square root function, this was the graph of root x plus 1, and then plus 1, and I still use the same x values. Notice here, it's when x is greater than 0. Nothing happened horizontally here, everything happened vertically. Therefore, the x values are still applied to this expression for the same values over here, meaning x is greater than 0. Okay? And another way that I could have written this is I could have said, all right, well, this is the function, not h, this is the function f of x. Vertically shiftwards upwards of 2 units means that'd be x plus 2. That means that this 2 applies to the function expressions only, not to the horizontal information. Think of the function expressions as vertical information and the domain restrictions as horizontal information. If I'm doing a vertical transformation, that is only affecting the vertical information, not the horizontal information. That means that f of x plus 2, I'm simply going to add 2 to each expression. And add 2 here, that would give me root x plus 3 when x is greater than 0. Okay. All right, in practice, that's how I'm going to do a vertical shift, is I'm simply going to add whatever, or subtract if it's a shift downwards, add that constant to the function expressions and leave the domain restrictions alone. Thank you for watching, and if you have enjoyed this video or would like to watch others, please consider subscribing to our channel.